In this video, I'm going to show you how to use the VPN Gateway in VPC to connect an on-premise data center to a PowerVS workspace. First, let's create a high-level architecture diagram. Here you can see we have our PowerVS instance on the right with a network of 172.19.0.0/24. On the left, we have the on-premise location with a network of 192.168.0.0/16. We also have the IPsec configuration that the on-premise side will be using that'll be necessary later on. The first thing we need is a VPC in the same region as our PowerVS workspace. In that VPC, we'll need to deploy a VPN gateway. Next, we'll deploy a transit gateway in the same region and connect it to both the VPC and the PowerVS workspace. Lastly, we'll connect the VPN gateway to our on-premise data center. Now that we have a high-level architecture, let's go build it out. First, we need to create a new VPC, making sure to create this in the same region as the PowerVS workspace. When creating this VPC, give it a unique name, then be sure to uncheck the Create a Default Prefix for each zone checkbox. This is done because we want to make sure that the prefix we're using isn't being used anywhere else. Once your VPC has been created, click on it to bring up its details page. Next, click on the Manage Address Prefixes link. Here we will create two prefixes, one that will be used for the subnet our VPN gateway will use, and the other that matches the subnets we were using on-prem. The reason we do this is to make sure that the on-prem network will be advertised into the transit gateway that will be created later on. In this demonstration, we are using the prefix 172.20.0.0/24 for the subnet that the VPN gateway will be deployed on, and 192.168.0.0/16 to represent the on-premise network. Next, we need to create a subnet out of the 172 prefix for our VPN gateway to deploy on. Give the subnet a unique name and make sure that the correct VPC is selected. You can keep the defaults for the rest of the selections. Next, we need to configure the policies for the VPN gateway. First, we create an IKE policy and then the IPsec policy. It's important these policies match the configuration from the on-premise side. After the policies have been created, we deploy the VPN gateway. In this demonstration, we are going to create a policy-based VPN. In the connection details, ensure that the peer gateway address is the IP address for the on-premise endpoint, that the pre-shared key matches the on-premise key, that the local IBM CIDRs contain the networks used in your PowerVS workspace, and that the peer CIDRs contain the on-premise networks. In the policy section, be sure to select the IKE and IPsec policies we created earlier. The deployment of the VPN gateway will take a few minutes, so while that's going on, let's create an ingress routing table. This routing table is used to accept routes from the transit gateway. In the demonstration, we specify that the routing table will accept routes from the VPN server, the VPN gateway, and the transit gateway. Under the transit gateway section, select Advertise to. In the future, this will be used to advertise on-premise routes into the transit gateway instead of adding a prefix to the VPC. Lastly, we deploy the transit gateway. For this demonstration, we'll be using a local transit gateway deployed to the same region as our VPC and PowerVS workspaces. The first connection will be the VPC where our VPN gateway is, and the second connection will be the PowerVS workspace. Note that the order here doesn't matter. When the transit gateway has been fully deployed, check the BGP routing table to make sure all the routes we expect show up. For this demonstration, we expect to see 172.20.0.0/24 and 192.168.0.0/16 from the VPC and 172.19.0.0/24 from the PowerVS workspace. Finally, we can verify the tunnel is up by pinging and SSHing from the on-premise data center to the PowerVS server in IBM Cloud.